They've asked us to identify a few things here. Let's start with the axis of symmetry. The axis of symmetry, graphically what that means is that if you were to graph this guy, there's a place on a parabola, every parabola, where you could draw a dotted line and you could fold the two halves of the parabola together and it'd make the same picture. That dotted line is the axis of symmetry, and it's always an x equals something, because that's what makes a vertical line. So we got to find out what x equals for the axis of symmetry, and there's a quick formula. That formula tells you the location of the vertex, and it also tells you the equation of the axis of symmetry. If you plug everything in here, in our equation, our b is 4, our a is -1. So that's what it looks like when you plug everything in. You get out 2. X equals 2 is our axis of symmetry. Finding the axis of symmetry also helps you find the vertex, because now this is the x location of where the vertex occurs. To find out the y coordinate, you just have to plug x equals 2 in here, and what it'll spit out is your y coordinate. So that's what it looks like when you put in the x coordinate of the vertex. And so when you simplify, just make sure you do exponents first. That's a -4 plus 8 minus 2. So that gives you -4 plus 8 is 4, 2. That's the y coordinate. The vertex is at 2, 2. So on to the next number on our, the next thing we're asked for on our list, the y-intercept. The y-intercept is where the graph crosses the y-axis, and in a quadratic, it's nice and easy. It's c. So if you go back up here, we have ax squared plus bx plus c. -2 is our y-intercept. So we got that part. We're asked for the x-intercepts. That's where the graph crosses the x-axis. So that's everywhere where y equals 0. So I'm going to plug 0 in for f of x into the formula that we were given. And now I have an equation to solve. If I can solve this equation, I should get 2 solutions. Those 2 solutions represent the x-intercepts. The other way of doing this is graphing too. If you plug this in a graphing calculator, you might be able to spot the x and y intercepts. But if you can't factor this one could be done with a quadratic formula. So it's assumed you've done the quadratic formula before. That's why I'm going a little fast here. But this is what it should look like when you plug it in. And then when you simplify for x, you get this. But that square root can be simplified because you can pull out a perfect square root from it. Square root of 8 is the same thing as square root of 4 times square root of 2. And we all know what the square root of 4 is. It's 7. No, it's 2. So this is what it all simplifies to be. Okay? So if you want, you can convert those to decimals, but those are the 2 intercepts. When you do -4 plus 2 square roots of 2 over 2, and then we do -4 minus 2 square roots of 2 over 2. Those are the intercepts that they wanted for this question right here, the intercepts. So we need to sketch a graph of the parabola. We can use some of those facts. We said the vertex is going to be at 2, 2. 1, 2, 1, 2. And we'll put a big dot, not that big, big dot for the vertex. The y-intercept was -2, so let's put a dot right there at -2. And since this is the axis of symmetry, wherever the vertex is, let's make that a little bit more straight. These dots make the axis of symmetry. Because we had a dot 2 spaces to the left at -2, there's going to be a dot 2 spaces to the right at -2, because parabola is always symmetrical. So this is probably enough for a rough sketch of the graph. Okay, and it's opening downward. It's facing downward. And you can tell that also because A is negative here. But I think that's everything they're looking for. That's the sketch of the graph, the final piece.